Ladies and gentlemen, a report on the topic Route Selection Method in Military Information and Telecommunication Networks based on the Adaptive Neuro-fuzzy Inference System is offered to your attention. In modern military information and telecommunication networks, ensuring the quality of service for various information flows is one of the high priority tasks. An integral part of this process is the use of properly configured dynamic routing protocol. The dynamic routing protocol for such networks should be based on metrics that consider the reliability of intermediate nodes routers. Such provisions are currently implemented, for example, in the Enhanced Interior Gateway Routing Protocol, EIGRP. One of the promising solutions to the problem of obtaining the priori information is the use of systems for predicting the values of the required parameters. For example, network administrators have statistics of issues and failures of a particular type of equipment for a certain period of its operation. Failures are usually random and have various causes. Therefore, such a data set can be used to determine the failure rate in the future. The capabilities of modern forecasting systems are used to do this. One way to implement this is to use adaptive fuzzy neural networks. The routing procedure includes a number of steps: obtaining information about the components of the metrics that are transmitted in the packet header, calculation of the generic metric for available routes according to the routing protocol, describing the transmission of packets using a determined way. The use of ANFIS in such a context is considered in this paper. The general form of ANFIS is shown in Figure 1, Slide 2. The mechanisms that underlie ANFIS allow finding the functional dependencies in the form. However, obtaining the correct value using formula on Slide 2 depends on the correctness of the data of training such systems. Thus, one of the most common ways of training is the back-propagation method. The basis of the training sample is the data obtained during the observation of the input values and the desired values of the output. The internal structure of ANFIS is determined based on the number of input values, the number and the form of their membership functions, and the fuzzy inference algorithms. Figure 1, Slide 3. A method of route selection using ANFIS is proposed, which involves the following steps. Slide 4. The basis of any dynamic routing protocol is the calculation of the route metric. We propose to use such a routing protocol that considers the reliability index when calculating the route metric. In addition, the proposed method can be used for new dynamic routing protocols. One of the existing protocols is that consider the reliability in the calculation of the overall metric is EIGRP. However, the reliability index in this protocol is taken into account only if the network topology changed. Let's calculate the route metric using this protocol in the router R1 for the network architecture shown in Figure 1, Slide 5. Appropriate steps of the proposed method were executed to obtain the value Rnj. For the EIGRP protocol, the value of the reliability index is in the range of 1 to 255. Therefore, it is necessary to establish the correspondence of the obtained values of the reliability index Rj, which is in the range of 0 to 1, with the range of the EIGRP protocol. The paper proposes a gradation of the correspondence values, shown in Table 1, Slide 6. As input values, we use the value of the number of failures of the case class during the last 4 periods of time. As the output value, we use the number of the case class failures during the following time interval. It is proposed to use the Suggeno algorithm of the first type to obtain an accurate prediction. For each input value, 2 triangular membership functions were defined. Then, the synthesized ANFIS will have the following structure in Figure 1, Slide 7. The training of such ANFIS expressions for membership functions of input values were obtained. The values of the individual conclusions on the rules by Suggeno algorithm of type 1 are determined according to expression 1, Slide 8. Synthesized ANFIS consists of 5 layers. The result of defuzzification is a crisp value of the predicted number of failures of the case class. To teach ANFIS to predict the number of failures of the case class, test data were obtained by generating random numbers with a uniform distribution. The test sample was divided into 2 parts. The first part was used for ANFIS training. The method of inverse error propagation was used in the learning algorithm. The second part of the test data was used to verify the learning outcomes of ANFIS. The data used for training were organized in matrix. The training was based on the data for I equals 5000 cycles and was conducted in the MATLAB environment. After training, data from the second test part were submitted to the ANFIS input, and the initial value was compared with the expected result. As a result of numerical simulations, it was found that the accuracy of predicting the value is 94 to 96%. Conclusion, slide 9. The paper proposes an approach for updating route metrics using a priori data on the reliability of military network routers based on ANFIS. ANFIS allows getting the value of the reliability index, which provides an early decision on using backup routes in the next time interval and helps to ensure better QoS parameters. Further research aims to determine the dependentness of QoS indicators using the proposed approach in implementing the military telecommunication network. Thank you for your attention.